Hi you guys, welcome back. We are on lesson 6.4 today. We are talking about common denominators. So go ahead and find your workbook, your math journal. We are on page 346 to start with. You will also need your pencil and you might want your multiplication chart. Okay, so once you're on page 346, remember that a common denominator, that just means we're looking for a common multiple that two denominators have in common. So remember, multiples mean, let me grab my pen. Okay, multiples of 5, for example, would mean 5, 10, 15, 20. And then it could keep going on and on and on. So it's like you're counting by fives, or you might notice that that means 5 times 1, 5 times 2, 5 times 3, and so on. And so we're looking for multiples that two denominators have in common. So if you look at the bottom of page 346, number 1 says, find a common denominator for 1/3 and 1/12. by dividing each whole into the same number of equal parts. So again, one way to think about this is by using models. And so if you look at the models drawn for you, they are showing you 1/3 shaded on the first box and 1 out of 12 shaded on the second box. And they're asking you to see, is it possible to cut each big rectangle into the same number of parts? And so I don't know if you can see this right away, but 1/3, that box can actually, if you draw lines on it, be split up so that it also has 12 pieces. And so if you look at this now, when it has 12 pieces, instead of 1/3 being colored in, there's 4 out of 12 colored in. And the reason that we use common denominators is it makes it easier to compare fractions so that you can see right away that this fraction or this model shows more than the other model. And it's easiest to compare when the models are broken up into the same number of parts. So that was a long way to answer, but the common denominator here is 12. And if you think about it, these two numbers, 3 and 12, they have a common multiple of 12. So like if I list out the multiples of 3, 3 times 1, 3 times 2, 3 times 3, 3 times 4, 3 times 5, and then I did it for 12, 24, 36. You can see in the two lists that they both have a common multiple of 12. And so another way to do it would be to list them out. But either way, number 1's 12. So go ahead and flip to the next page, page 347, and we're going to practice using common denominators, but there's actually one more step. It says write the pair of fractions as a pair of fractions with a common denominator. So 1/2 and 1/4. So first you need to figure out what the common denominator is going to be for 1/2 and 1/4. I'm going to list the fractions over here. If you don't have enough room in your book, you might grab a piece of scratch paper. But 1/2 and 1/4, and you're looking to make two new fractions with a common denominator. So you're looking for a common multiple of 2 and 4. So if you can think right now in your head of one, that's fabulous. If you can't, you're probably going to have to list them out. So like multiples of 2 would be 2, 4, 6, 8. Multiples of 4 would be 4, 8, 12, blah, blah, blah. Right away, though, I see that they both have a multiple of 4. So I'm going to say that a common denominator could be 4. Okay, but before you just write 1 over 4 and 1 over 4 as the new fractions, you can't just change the denominator. You have to also make sure that the numerator gets changed also so that the two fractions stay equivalent. So on the bottom one, 1/4, it's already in fourths, so I can just leave it as 1/4. So this is one of our fractions, but the 1/2, it's not going to be 1/4 also, because if you think back to equivalent fractions, can you guys see the pattern that they're doing? You're doubling it, you're doing times 2. So the numerator will be 2. So the two new fractions with common denominators are 2/4 and 1/4. Go ahead and look at number 3. List your fractions off to the side. 3/4 and 5/8. And you're basically just trying to make equivalent fractions, but you want them to have the same denominator. So find a common multiple of 4 and 8. So if you need to list them out, go ahead. 4, 8, 12. Although if you have your multiplication chart, this is what each row, this is what the row of 4s should say. So you could just compare the row of 4s and the row of 8s and see which multiple they would have in common. And then for 8, you would have 8, 16, 24. But look, they have an 8 in common. So you know that a common denominator could be 8. So put an 8 here, and then you want to make equivalent fractions. Now the bottom one is already in 8ths, so this can stay as 5/8. The 4, though, to get to 8, you'd have to multiply by 2. So whatever you do to the bottom, the denominator, you also have to do in the numerator to keep it equivalent, just like what we've been doing. So your two new fractions would be 5/8 and 6/8. All right, if you're feeling confident, go ahead and try 4 and 5, and then 6 and 7. Otherwise, you can work them out with me as well. I'm going to scroll down a little. So for number 4, 1/3 and 1/4. So compare on your multiplication chart the list of 3 and the list of 4 and see what multiple they have in common. I think that the smallest multiple that they have in common is 12. So if you put a 12 as the new denominator, you're going to have to change both numerators. So see what you're multiplying by. I know that 3 times 4 is 12, so I know I also have to do that to the numerator. So the first fraction is 4/12. And the second fraction, I know that 4 times 3 is 12, so keep that equivalent by doing it to the top. So the other fraction is 3/12. All right, and then go ahead and look at 5. You have 4/12 and 5/8. All right, you're going to have to look for a multiple here. If you list out the multiples of 12 or look at your multiplication chart, looks like this. And for 8, you get 8, 16, 24. So I see they both have a 24 in common. So if 24 is the denominator, now figure out what the new numerator will be. So on 4/12, 12 I know times 2 is 24, so now you have to do times 2 on the top. So the first one is 8/24, and then the second one 8 times 3 is 24. So if you do 5 times 3, you get 15. Alright, if you haven't already, pause the video, try 6 and 7 on your own, and then check your answers. Okay, number 6, 1/4 and 5/6. 1/4, 5/6. Think about what number or what multiple they have in common. I know that they both have 12 in common. You also might see 24. The cool thing about these is if they have more than one multiple in common, as long as you're multiplying by the right numbers, you still should get equivalent fractions. I'm going to do 12 though because it's a little smaller. I know that 4 times 3 is 12, so if you do 1 times 3 on the top, the first fraction is 3/12. And down here you did times 2, so this must be 10/12. Alright, go ahead and try 7. You have 3/5 and 4/10. Alright, I know a multiple of 5 is 10 because you count by 5s, 5, 10, 15, 20. So if you change the denominator to 10, on the first fraction you did times 2, so you get 6/10. But on the other one, it's already in tenths, so you don't need to change anything at all. So you have 6/10 and 4/10. Okay, pause here. The next section is a review. See if you can figure this section out. Tell whether the fractions are equivalent, right? Equal or not equal. Alright, 3/4 and 1/2. These are not equal. Because, well, you can think of it a couple different ways, but if you think, actually, I'll show you this way. If you think about it like this, 4 divided by 2 is 2, but if you did that to the top, it's divided by 3. And so since they're not the same, they're not equal. Number 9, 3/4 and 6/8. Those are equal to each other because I know 4 times 2 is 8, and on the top, 3 times 2 is 6. Number 10 is equal because on both the numerator and the denominator, we did times 4. And then lastly, on the last one, they are not equal, and you really can just see that right away because they're both talking about eighths. And is 6/8 equal to 4/8? No, so they're not equal. Alright, finally, number 12. Jerry has 2 same-size circles divided into the same number of equal parts. So don't let that confuse you. Basically, he has two circles. One circle has 3/4 of the part shaded, and the other has 2/3 of the part shaded. His sister says the least number of pieces each circle could be divided into is 7. Is his sister correct? So 3/4 and 2/3. Could those both be divided into 7 parts? Think about that for a minute. Pause here if you need to. The final answer, though, is no. 3/4 and 2/3 cannot be divided into 7 parts. 7 is not a multiple of 4 and 3. I think his sister was probably thinking of adding, because if you look at the multiples of 4, you get 4, 8, 12, 16. For 3, you get 3, 6, 9, 12. There's no 7 in either list, so I know that 7 would not work. The correct answer would be 12 because that's the smallest multiple they have in common. So you could add the smallest number of pieces each circle can be divided into is 12, because 12 is a multiple of 3 and 4, a common multiple. All right, so we are going to go ahead and stop here. Please let me know if you have any questions at all, but this lesson is basically putting together everything you've learned so far in Chapter 6. So now we're looking for common multiples to find the common denominator, and we're using our knowledge about equivalent fractions. So again, let me know if you have any questions or you need any help.